Hi, in this video I'm going to talk about resting membrane potentials. So this is the first in a series of videos that explains how action potentials work. But first of all we have to talk about this phenomenon called the resting membrane potential. So I'm going to draw an ion transporter in a membrane of a cell. And for our purposes we'll call this a neuron, but many different cells have this transporter. This transporter is a sodium-potassium, ATPase, and it switches 3 sodium for 2 potassium. And to do this, it needs ATP, which is the energy source of the cells, and it converts it into ADP and inorganic phosphate. Now, because we are pumping 3 positive ions out of the cell and only 2 positive ions in, we get an excess of positive ions on the outside of the cell. And conversely, we get a deficit of positive ions in the cell, which causes an effective negative ion excess. Now, because they attract each other, they line up on either side of the membrane, but they can't cross the membrane, and this leads to an electrical potential difference, also known as a voltage. Because some of the ions can flow across the membrane by other means, a steady state is eventually reached. And this means that the voltage across the membrane stays constant. This is called the resting membrane potential. And in neurons, this potential is about 70 millivolts in magnitude. Now furthermore, there is also a higher concentration of sodium outside the cell than inside. So sodium would like to move down its concentration gradient, but can't because there is a membrane in the way. Similarly, there is a high concentration of potassium in the cell and a lower concentration outside the cell. So it would like to move down its concentration gradient too, but can't because of the membrane. In summary, there is a positive to negative gradient this way, and there is a high sodium to low sodium gradient also this way. And there is a high potassium to low potassium gradient the other way. And this sets the scene for an action potential. Finally, let's look at what happens when you record the voltage inside the cell. We're looking at the voltage across the membrane versus time. And we can see that in a resting membrane potential, the voltage stays steady. This will differ when we have a look at an action potential. We'll talk about voltage-gated ion channels in the next video. For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.